let's use time value of money principles to price bonds. Now, unlike stocks, bonds are relatively easier to price because bonds, by definition and construction, have finite ending dates. So they're much cleaner to isolate in terms of cash flows occurring than stocks. Stocks are messy because we don't know what the cash flows are associated underlying stock cash flows are going to be for how long. Those are all assumptions we need to make when solving for stock prices. With bond pricing, however, those a lot of those problems are not there by design, right? So in bonds, if you recall, we have these periodic coupon payments, which are denoted on this timeline by the x's, and then at maturity, which in this example happens at time 7, you get the your coupon as well as the face value back, which is $1,000 for corporate bonds. And so that this kind of a payment structure is fairly standard with bonds. And that makes it a much cleaner problem to solve. Of course, an assumption that we make here that it's unstated but sort of there is that there is no bankruptcy risk. In other words, we assume that we're going to get this money at these promised times, and that's the end of the story. And if you add likelihood of bankruptcy, it just makes things a little more complicated, but doesn't change the story. So we'll just stick to this example for the moment and understand that. So if we have to break down the problem in terms of annuities and single sums, notice that the cash flows associated with a bond comprises of two parts. The annuity stream comprising the periodic coupon payments, which in this case you see with the X's, and then a single sum of the face value or the $1,000 that occurs at maturity. So if we have to calculate the present value or the price of this bond now, then we have to do it in two parts. One is that we need to move those coupon payment annuity stream to the present, and also move that $1,000 face value payment at maturity as a single sum, move it to the present, and then add those two things up at the present, and then that's our present value or the price of the bond. Okay, so that's sort of the thing to keep in mind. And all bonds, pretty much, that we'll talk about operate in this way with some variations. But so it's it's an annuity series as well as single sum. And we'll need to discount both of those back to calculate the present value. Likewise, if we need to calculate the future value, we do the same thing with the annuity stream and the single sum and move those two to wherever is needed in the problem. So keep that in mind.